before. We were going to quadruple the amount of time spent by a human being in space, from 14 days to 56 days. And as it turned out, we did better than that, went 84 days on the third flight. The system we expected to change fastest in the body was the cardiovascular system, the heart, the blood vessels, the amount of blood in them and the way they operated. So our number one experiment to stress that system was called lower body negative pressure. Well, we didn't have gravity up there, so we couldn't stand up, and the lower body negative pressure is a substitute for gravity, a way to fake the body out. And we ran that at 4-day intervals throughout the mission, and from the very first time we ran it, it was obvious that there were indeed changes. But the encouraging thing was that these symptoms were present the very first time we did the test, and they didn't get worse as time went on. There was another major dynamic test or stress test that we used to determine our condition in flight, and that was the bicycle ergometer. You simply worked your heart, your muscles, and your lungs to the maximum capacity to see whether they all played together the same way in the absence of gravity. We found that our ability to exercise, our heart's ability to move blood around the body, the cells and muscles' ability to extract oxygen from it, and all the processes that go into a maximum exercise were completely unaffected by zero gravity.
It was also considered important to check the response of the vestibular system, or the little balancing mechanism within the inner ear. And we did this by means of a rotating chair. Now, normally when you sit in this chair and rotate on Earth and move your head, it doesn't take very long before you experience motion sickness. However, up there we noticed that after we were there a few days, it was possible to sit in this chair and rotate almost all day long with no sensation or motion sickness at all.
We took blood samples periodically throughout the flight, mainly to make sure that the hemoglobin level in the blood was maintained at a proper level and that the body was responding properly to lowered levels of hemoglobin or red blood cells, to make sure that there was not some sort of subtle effect taking place in zero gravity that would leave us more or less open to infection, say.
On our mission, we elected prior to the launch to increase the exercise period from an hour to an hour and a half. And this was done mainly on the basis of recommendations of the previous crew. They felt there just was not enough time for a good exercise period, that you really needed more time. We were also bringing up the little treadmill, which was going to require time for use, so we just ended up going for an hour and a half per day exercise. It appears that that decision was a good one, because we came back, I think, in better condition than has any other crew.
The Skylab medical experiments were perhaps one of the most important things we did during the whole Skylab mission. We attempted to take a look at man as he reacted under long-term weightlessness. Whether or not we can extrapolate that 84 days out to several hundred days, incidentally it takes something like 400 days for a typical Mars mission, we don't know right now. But it does indicate that we're on the right way to in assuming that man can exist for long times at zero G.
The sun turns out to be a giant astrophysical laboratory. It is made up of plasma. That's high-temperature gases, which we plan to use down here for many schemes in energy production. And we can use the sun as a laboratory to better understand how plasmas are affected by electric and magnetic fields, how they're moved, what their properties are.
There were a number of really fascinating views available from Skylab in the area of the solar study, some of them seen for the very first time by human eye. In this case, there was an eruptive prominence on the disk of the sun, which cast out through the solar atmosphere, called the corona, to very, very high altitudes, an expanding gas bubble. This was moving out through the corona at a velocity of about 300 miles per second. And we brought back a number of very fascinating views of these sorts of events.
Well, on our flight, we were fortunate enough to be able to, first of all, record a solar flare from the very beginning all the way through the rise to the end, based upon the previous experience of a other crews, we were able to figure out what happens before a flare, then beyond target, and getting data as the flare came up.
We also know that when these large flares erupt on the sun, they throw out charged particles which reach the Earth in some 24 to 48 hours. These produce aurora, which we see here on Earth.
Well, the observation of Comet Kohoutek offered an unprecedented opportunity. It was very bright, and most notable was a sunward spike, which was in the opposite direction of the tail, very sharp and pointed towards the sun. Comets are important to science because we are able to observe what we think is primordial matter. That is, matter which has been around since the birth of the solar system, if the comet came from the solar system, or if it came from outside the solar system, then it's an opportunity to observe something which was not created with our solar system, but in the regular stellar scheme of things.
We also had several smaller experiments intended to look at the ultraviolet radiation coming from stars throughout the galaxy in which we're in, as well as radiation coming even from other galaxies. And these experiments were extended out the scientific airlock of the Skylab and looked at the ultraviolet radiation coming from the sun, allowed it to be dispersed so the image actually looks like it has a long tail on it, and then he can see just what radiation is coming from each of these stars.
Throughout the 3 manned missions, flight crews evaluated the day-to-day activities of living to see what might be improved in future spacecraft design.
Mobility was, I like to refer to it as the Peter Pan mode. You could really just push off and move around. Within the workshop, the thing that surprised me most was how quickly we all adapted to being fairly precise.
It's very much like the sensation you get when you're skin diving or just floating around in the water.
Well, as far as working in zero gravity and moving yourself, it was a delight in comparison to 1G on the surface of the Earth.
Once your eyes see something, then you relate to it, and you say, whatever is above my head is up, whatever is below my feet is down. Doesn't matter whether it's the floor or the ceiling.
Every evening after dinner and all the work was done, we always had to take a trip or two around the water ring lockers or just go up there and free fly.
We also found that we could have quite a bit of fun doing tricks and stunts and flips and rolls that weren't possible here on Earth. Food aboard Skylab was a very good treat when compared to earlier space missions. Probably the best feature was the fact that we had the ability through a warming tray to put all of our food out and heat it so that when you sat down to eat, you could eat a variety of foods all at once. Probably the favorite of everybody's up there was ice cream and strawberries.
Of course, it was necessary to clean house up there once in a while, too. All of our air was filtered through a big screen within the orbital workshop. And as the air went through this screen, little particles would collect on the screen, small items that needed to be vacuumed up. And so every day or two, we would vacuum off the screens.
We found housekeeping to be not as difficult as here on Earth. One reason was that we had a planned place for every item.
Personal hygiene-wise, it was necessary for us to perform up there about the same way it is here. We brushed our teeth, we combed our hair, we shaved, we washed. We did have a shower. We found, however, that we could almost keep clean enough by using sponge baths, by washing ourselves off with a wash rag. Although we did use the shower on several occasions, and I think for future space stations, the shower would be a good idea.